Okay, another type of variable is a matrix or matrices. Matrices are a lot like data frames in that they're two-dimensional array of values. The difference is that matrices have to be the same data type, whereas data frames can have fields or columns that contain different types of data. With a matrix, all of the data have to be of the same type. But other than that, they're the same as data frames. They're two-dimensional structures. So here, we can make a matrix. So the command to make a matrix is not surprisingly called matrix. And we can fill it with the values 1 through 6. And we can specify the number of rows as 2, the number of columns as 3, and we can fill it by rows. So this is going to make 1, 2, 3, 4, 5, 6, right? So we've made a matrix this way. It's two-dimensional, and all the data inside it are of the same type. They're integers. You can also fill matrices by columns, so have it do 1, 2, 3, 4, 5, 6 by setting this by row argument to false, but we won't come across this too much in our work. So just like with data frames, we can refer to specific rows, columns, and cells using brackets in the same way. So to do this, let's create a new matrix called myMatrix, and we're going to assign to it, like what we just did, a matrix. We're going to fill it with the values 1 through 6. It's going to have 2 rows, 3 columns, and we're going to fill it by columns. So it should look like this. So just like with a data frame, you refer to specific positions in a matrix with these brackets, and there's 2 positions because it's two-dimensional. There's 2 positions in these brackets where the first one specifies rows and the second position specifies columns. And if you leave it blank, it means all. So to get the first row of a matrix, we put a 1 in the row position and leave the column position blank, and that will subset out the first row. Similarly, we could do the second row, or the first column, the second column, or different subsets of that. So we could get the second row and the second and third columns by using this sort of notation. So exactly the same idea as with data frames. So again, practice with this. You should type in these different commands so that you start to get comfortable subsetting data in this way. Okay, another important type of variable in R are what are called factors. So a factor is a vector where the elements are categorical values that could also be ordered. So the values are stored internally as integers with labeled levels. So again, that sounds very abstract. So let's work with this. So let's create a new vector using the combine function, and let's type in, you should type in all of this. So our vector is going to contain the word high, the word medium, the word low, the word high, then the word medium. So this is a new vector of text, and we're calling it x. And now we can convert that vector to a factor by using this factor function. So we're going to say call a new variable called xf, so our x variable, but we're going to make it a factor. That's what the f is there for. And we're going to use the factor command. So we're going to convert our x vector into a factor. And so now if you do that, then if you type xf and hit enter, it tells you what we have. So high, medium, low, high, medium. So this is the data. And it tells us, so R has recognized that there's 3 levels, high, low, and medium, right? So now it's a factor where R recognizes that this text refers to specific levels or specific values. And so R has recognized that there are 3 categories, and it's actually given each a number. It hasn't shown us that, but it has done that in the background. We can get what numbers R has assigned to them with this as.numeric function. So if we type as.numeric xf, it's going to give us these data, but in the numeric format. So 13213. And so you can see it's given 1, it's assigned high a value of 1, medium a value of 3, and low a value of 2. So that might not make sense, but this is what R does by default. By default, R numbers levels and factors alphabetically. So that means high would be 1, low would be 2, and medium would be 3. And you can see in this case that's not very intuitive, right? You'd think that high, medium, and low should be sequential here, right? But R has done this alphabetically. But you can specify the order if you want to. So, for example, so now I'm making a new variable, xfo, so this is our original x variable, but it's a factor, and then I'm putting an O here for ordered, so xfo. So it's a factor with x from our original x vector. And now we're going to tell R the levels and what order to use them. So we're saying the levels of this are, and here we're combining values, so we're using that combine function of low, medium, and high. So now we're telling R that these are the 3 values, and we're telling R that this is the order we want you to number them in. So now it'll give low 1, medium 2, and high 3. So we can see that. So now xfo, our text is staying the same as what it originally was. But now R knows, okay, there's 3 levels. Low is less than medium, which is less than high. And then if we look at the numbers that R has assigned to those values, we can do the as.numeric xfo. And we can see now high is 3, medium is 2, and low is 1. And this makes a little more sense, right? So again, factors are categorical values, and then R will assign them a number. And that's very useful because we want numbers for our models that we're building, but we also want to refer to the text that refer to those numbers as well. So we'll use factors a lot with our models when we're dealing with categorical data types. Okay, there's one more type of data, of variable types that I want to talk about, and these are called lists. So lists can be a little tricky to get your head around. So a list is a vector where the components can be different types. So a list is a list of things, not a list of values, right? A list of values would just be a vector. But a list is a list of things. And again, that's abstract. So let's look at an example. So let's say we have a list of 4 components. Component 1, instead of being a value, it could be an entire data frame. And component 2 could be an array. We didn't actually talk about arrays. Component 3 could be a matrix, and component 4 could be a totally different list. So again, a list is a list of things, not a list of values. And this is useful for combining a bunch of different types of information together into one kind of structure. So as an example, let's make 3 different variable types and combine them into a list. So first, let's make a vector. We're going to call it A, and it's just going to be a vector of integers. So A is going to be 1 through 5. B is going to be a matrix. It's going to contain the values 1 through 6, and it's going to have 2 rows and 3 columns. C is going to be just text. So it's going to say, when will all this get interesting? And then we can combine these into a list called myList. And we're going to use the list function to make this a list. So we're going to say combine A, B, and C into a list. And we're going to call that list myList. Okay, so you should type all of those into the command line. And now we can see what this looks like. So if you type myList, you'll see the first component is our vector from 1 to 5. Our second component is this matrix of 1 to 6 with 2 rows and 3 columns. And our third component is this text, right? So a list is a way to combine a bunch of different things. Just like with data frames and vectors and matrices, we can refer to different parts of lists. But now we have to do it a bit differently. So now there's 2 components. In double brackets, you refer to which component of the list you're referring to. And then in the second set of brackets, it's the same as with a data frame and matrix. And so it depends on if it's a vector or a data frame or matrix. Depending on what this component is, you can use 1 or 2 positions here. So let's look at this. So if we want to know, okay, just show me the first component of the list, we just put the 1 in these double brackets, and it will, if you type this in and hit enter, it'll just give you these values, because that's the first component of the list. Similarly, if you type my list, then in double brackets hit 2, it'll print out the second component of the list, and so on. The same thing for the third. But we can still refer to specific positions inside each component of the list using another set of brackets. So if we want the second and third values in the vector, that's the first component of our list, we specify we want the first component of the list and the second and third positions. Similarly, if we want the first row of the matrix, that's the second component of our list, we specify the second component of the list here, and that we want the first row in all of the columns. And so on. This second part's exactly the same as what we talked about with data frames and matrices, except for now we just have to mention which component of the list we're talking about. So to get the second column of our matrix, that's the second component of our list, we specify the second component here in the double brackets, and then we want all rows of the second column, and so on. Okay, one last thing when dealing with R is missing data. R does not like missing data, and so you can't have blank spaces in R files. Instead, missing data should be indicated with NA, so not a backslash in here, just the letters capital NA. And so you need to ensure that your data are in this format prior to loading them into R, otherwise you're going to have problems. And so you can do that using find and replace in Excel or whatever, however you do find and replace, but you obviously have to be careful when you're doing that. But it's important to know that if you have blank spaces in your data, that's going to cause problems with R, and you need to replace those with NA before loading your data into R. Okay, that's going to end this component of our introduction to R. So we'll stop there for now, but there will be more videos.